This is Unit 3 Notes, Writing Quadratic Equations. So before we write these quadratic equations, we are going to label all the attributes of a quadratic function. So first, we're going to start off with the vertex. I'm going to color code it to the graph so you have an easier way to see it. Okay, so this is the vertex. We know that the vertex can show either the maximum or minimum value. So if our parabola is pointing down, then we know that we have a maximum, which also implies that our a value is negative. And if our parabola is facing up, you know we have a minimum value and that our a value is going to be positive. We also know that we can write our vertex as a point h, k. And this is important to know when dealing with the vertex form. So I'm just going to draw an arrow connecting the two boxes. The next one is the axis of symmetry. So remember, the axis of symmetry is the line that divides the parabola in half. I refer to the axis of symmetry as the AOS. We know that the axis of symmetry is always the x value of the vertex, so x is equal to h. And if we do not know the vertex, we can find it using the formula x is equal to negative b over 2a. However, it's important to note that we can only use this if our equation is in standard form. So only if it's in standard form. And remember, standard form is ax squared plus bx plus c. Once we find this x value, we can take it and plug it in to find the y value. Next, we're going to look at the x-intercepts. A parabola can have up to 2 x-intercepts, but they could also have only one or they could have none, depending on where this parabola is located on the graph. So this is the x-intercept. We know something is the x-intercept if our y value is 0. So this is our y value. Last year in Algebra 1, you probably remember learning about the acronym ROCKS. And what ROCKS stands for is roots, zeros, x-intercepts, and solutions. These are all names for the x-intercept. Okay. So if the question is asking you to find the roots, you know that it's asking you to find the x-intercept. If it is asking you to find the solutions, again, it is asking you to find the x-intercepts. And then lastly, we have the y-intercept. And the y-intercept, we know is the y-intercept if our x value is 0. So the opposite of the x-intercepts. Okay. We also know that it is the value of c in standard form. So in standard form, our ax squared plus bx plus c, our y-intercept is 0, c, whether that is positive or negative. Okay, so those are our attributes. Okay, now let's look at the different types of forms that our quadratic equation can be in. So first, we have standard form. Standard form is y equals ax squared plus bx plus c, where a and b and c are all numbers. Again, I'm going to point out that the c value is the y-intercept, labeled as 0, c. Then we have vertex form. In vertex form, we use this to find the vertex. So this is helpful to find the vertex. Okay. And we also know when we are finding our vertex h, k, we can't just take whatever this h value is here. We have to take the opposite sign. So if this says -5, then our h value is 5. If this said +5, then our h value is -5. And then lastly, we have the intercept form, which is also referred to as factored form. And here, this form, y equals a, parentheses x minus p, parentheses x minus q, is helpful to find the x-intercepts. Helpful for finding x-intercepts. And these x-intercepts are labeled as p and q. Now let's look at an example. So in the next couple examples, we are writing quadratic equations in vertex form. So first, looking at our graph, we have to find the domain and range. So we know for quadratics, just like absolute values, the domain is always -infinity to +infinity. Our range is always going to be our lowest and greatest y values. So we have 1 here, so that looks like it is at 3. So we're starting at 3 as our lowest value and going to infinity. Our axis of symmetry is actually this red line here, and they give us the equation for that, and that is x is equal to -1. Looking at our parabola, our vertex is at the bottom, so that tells us we have a minimum value. And then the increasing and decreasing part is something new to you. So looking at our parabola, notice how our axis of symmetry completely cuts our parabola in half, which means we can examine the left side and we can examine the right side. So based on each of the sides, we can say that one side is decreasing and one side is increasing. So if we look at the increasing side, notice from the axis of symmetry at x equals -1, so -1, onward, this looks like it's going in the positive direction. It is increasing. Okay. Versus starting at our lowest point on the x's, which would be -infinity, notice how this one, as we go closer to our axis of symmetry, this is decreasing. So that means that our right side is increasing and our left side is decreasing. So we would write that as -1 to infinity and -infinity to -1. Notice how this -1 and this -1 all match our axis of symmetry's -1. Okay, it's going to be the same every time. Okay, now it wants us to write our equation in vertex form, which means we need the vertex. So the vertex here is going to be -1, 3. And then a point would be any point on that parabola. So I am going to do, let's see, 1, 5? Yeah, 1, 5 right here. 1, 5. Okay, so again, that is my HK value and my XY value. So plugging it in to solve for A, I get 5 is equal to A, parentheses 1 plus 1 squared plus 3. Notice how this turned into a +1, even though this is a -1. That is because of that negative in the formula. So minus a negative is plus a positive. Okay. So then we have 5 is equal to A. 1 plus 1 is 2. 2 squared is 4 plus 3. I'm going to rewrite this with the number in front of the variable. So 5 is equal to 4A plus 3. Subtract 3 and I get 2 is equal to 4A. Divide by 4, A is equal to 1/2. So that means writing my equation, I have y is equal to 1/2 x plus 1 squared plus 3. So that is the vertex form of the graph given above. Okay, now let's look at the vertex form of example 2. So again, looking at our graph, we know domain is always -infinity to +infinity. And then looking at our range, we're going to look at the lowest y value and then the tallest y value. So our lowest y value is -3, so this is -3. And since we have the arrows at the top, our tallest y value is going to be infinity. Next, our axis of symmetry is going to split our graph in half, and it's going to be an equation where it crosses the x. So this is x is equal to -2. And since our vertex is on the bottom here, we know that this is going to be, again, a minimum. And then we have to decide if which side is increasing and which side is decreasing. So since our graphs look the same on example 1 and example 2, we know it's going to be the same side that is increasing versus the same side that is decreasing. So the increasing side is going to be the right, and the decreasing side is going to be the left. Okay, so remember we start with our axis of symmetry, so -2 to infinity. Then we start with our -infinity and end with our axis of symmetry of -2. So that is the values when it is increasing and decreasing. Okay. Then we need to find our vertex, which is -2, -3. And then any point that falls onto this parabola. So right here, 1, 0 would be a great point. Okay, and we know our vertex is HK and our extra point is XY. So plugging it in, I get 0 is equal to A, parentheses 1 plus 2 squared minus 3. So this is 0 is equal to A. 1 plus 2 is 3. 3 squared is 9 minus 3. I'm going to put the 9 in front of our variable just because that's the proper way to write it. So 0 is equal to 9A minus 3. We're going to add 3 to the other side and get 3 is equal to 9A. And then divide both sides by 9, and I get A is equal to 3/9, which reduces to 1/3. So writing my equation, I have y is equal to 1/3, parentheses x plus 2 squared minus 3. Okay, now let's look at example 3. Example 3, instead of giving us a graph and having us find the information, now we are able to just look at the information provided and then write our equation. So it gives us our vertex at 3, -2, and it gives us our extra point at 5, 6. So we know this is HK and this is XY. So I have 6 is equal to A, parentheses 5 minus 3 squared minus 2. 6 is equal to A, 5 minus 3 is 2, 2 squared is 4 minus 2. I'm going to write my 4 in front of my variable. So this is 6 is equal to 4A minus 2. Add 2 to the other side. I get 8 is equal to 4A. Divide both sides by 4, and I get A is equal to 2, which means my equation is y is equal to 2, x minus 3 squared minus 2. Okay, and that was writing all the quadratics in vertex form. Now we're going to write the quadratics in factored form, right here, factored form. So first, just looking at our graph, we know our domain is always -infinity to positive infinity. We know our range is going to be our least y value and then our highest y value. So our least y value, since this is upside down and the arrows are pointing down, is going to start at -infinity, and it's going to go all the way up to the y value of 1. Our axis of symmetry is what splits this equation in half, and so we know this is the equation x equals 2. And our vertex is at the top this time, which means that we have a maximum value. And then since our parabola is now facing down, you're going to notice that our increasing and decreasing values are going to switch. So now our left side is increasing and our right side is decreasing. So we would still write it the same way. We would take our lowest value, -infinity, to our axis of symmetry, which is 2. And then take our axis of symmetry 2 all the way to the right side, which is going to infinity. Then we're going to write it in factored form, and in order to do that, we need our 2 x-intercepts. So zooming in here, I see that I have one x-intercept at 1 and the other is at 3. So I'm going to write that here. So I have x is equal to 1, x is equal to 3. And then I need to find an extra point on this graph. So I am going to choose, let's see, 4, -3 right here. 4, -3. Remember, that's any point on our graph. Okay. So now using the intercept equation, I know that my x values are labeled as P and Q, and my extra point is x, y. So plugging everything in, I get -3 is equal to A, parentheses 4 minus 1, parentheses 4 minus 3. Okay, simplifying this, I get -3 is equal to A, parentheses 3, parentheses 1, because I simplified each of the parentheses above. And then I get -3 is equal to 3A, because 3 times 1 is 3, and I put the 3 in front of my variable. Divide both sides by 3, I get A is equal to -1, which means I have y is equal to -x minus 1, x minus 3. That is my answer. Okay. Same thing on the other side. Looking at my domain, I know it's always -infinity to positive infinity. My range, I'm looking at my smallest y value all the way to my greatest y value. So my smallest y value is -1, and my largest is infinity because of those arrows. My axis of symmetry is what splits this in half, and they already give this to me at x equals 2. My vertex is on the bottom, so I know that this is a minimum. And since this parabola is now facing up, just like examples on the front, we know that my increasing and decreasing parts are going to be exactly the same as the other example. So I know that this is decreasing on the left side and increasing on the right side. So I would take my increasing part, start with the axis of symmetry, which is 2, and go to infinity. And my decreasing part, start with negative infinity and end with my axis of symmetry, which is 2. Okay. Then in order to write it with this equation in mind, I know I need to find my two x-intercepts. So I have one at 1 and the other at 3. So x equals 1, x equals 3. In my extra point, I'm going to use, let's see, I'll go ahead and use the vertex right here because we can use any point on the graph, including the vertex. So I'm going to use that vertex point of 2, -1. Okay. So then labeling this is still my P, Q, and then my X, Y. So I have -1 is equal to A, parentheses 2 minus 1, parentheses 2 minus 3. -1 is equal to A times 1 times -1. So -1 is equal to -1A, so A is equal to 1. So I have Y is equal to A. So since our A is 1, I don't have to write it. X minus 1, x minus 3. Okay. And then my last example here, they already give us the values. So it gives me my extra point of 2, -1, and it gives me my zeros of x equals -1 and x equals -3. So I know this is my P and Q value, and this is my x and y. So plugging it in, I have -1 is equal to A, parentheses 2 plus 1, because it's minus a negative, and then 2 plus 3, because again, minus a negative. So I have -1 is equal to A times 3 times 5. So -1 is equal to 15A. I multiplied them and put them in front of A. Divide both sides by 15, I get A is equal to -1/15, which means my equation is y is equal to -1/15 x plus 1, x plus 3.